All right. So before we get into this week's cipher, we're going to quickly go over the Visioneer cipher from last week, which I left off. I didn't have this part of the code, and you guys had to think of a way to do this. All the submissions did have something that worked, but everything was a little bit longer. I'll just quickly run through my NCipher code, and the only difference that you should notice here between NCipher and DCipher is a minus, whereas a plus. So first thing we have is the sums of our two. Let's remember the tabula recta. We have the letters, which is up here in this alphabet. Find from the text, which is our original. Find this given position, and then we're doing the exact same thing, but finding it in the key stream and adding them modulo 26. Shouldn't be new stuff, modulo 26, because we have an alphabet with 26 characters in it. And then just like every cipher we've done so far, the output, we have a plus equals the letters from this. And this one I decided to do the text block and uppercase it, so you can see here they're in blocks of 5. And then going backwards, yeah, it's the same thing. You just want to find the text minus the key stream, because we're going backwards this time. So that was fairly simple, and this is class. We're going to have another tabula recta in Cipher. We're going to have the auto key, which is just a little bit different. If you remember, the Visioneer cipher had a key that you created, and that key would create a key stream, which was the repeated characters of it. So, like for this example, if our key was YTAC, our key stream would be YTAC, YTA to fit the amount of characters. But auto key is a little bit different. We're going to keep the same key is YTAC, but then our actual, well, we're not going to call it a key though, not necessarily. We're going to call it this a primer. This is, goes in beforehand, and this is what changes the result. So how it works is I'm actually going to make this a little bit longer, just so you can see how it really works. We have our auto key, and then we take our primer, which is YTAC, and then we're going to get our key stream, which is then just the rest of it minus the however many characters this is. So, auto key cipher, this is 4, 3, and 6, so this is 13 characters, and then YTAC auto key CI, this is also 13 characters. So then once it lines up, you can then go through the tabula recta and look through it. So A to Y is Y, U and T, we go U, and we find T right here. Yep, U and T is N. So you can go through like that. And that's how it works. It's very similar to Visioneer, but just a little bit different and just a little bit more secure. Before I go into the how this works, I'm going to talk about why it's more secure and why these polyalphabetic ciphers, which is the past Visioneer and auto key, why they are better than just using the Caesar cipher or just one of those simple shift ciphers that we've been using. Those ones were monoalphabetic ciphers, which means that there was just the one alphabet. If you look across, you just have this top row, and then you would just shift it. They're still the same output, and there are 25 possibilities, with 1 to 26 being the original. The reason these are special is because instead of 26 possibilities for every character, there are well over that. I believe, off the top of my head, it's something like 625 options. But what's important about it is that we have way more security. No one was actually able to submit a brute force cipher for Visioneer, and that's good. That just can go attest the claim of this cipher, which has been around for hundreds of years. This tabula recta was invented in the 1500s, early 1500s. So, as we're getting through, you have to have more more brain power, more advanced computing, maybe some AI in order to get it. So that brings me into why this is stronger than the Visioneer and by previous monoalphabetic. Um, it's I wouldn't necessarily say it's much stronger than Visioneer, but it is definitely different. You can see that it just has the original plain text posted on the end of the primer, and then you add it versus just plain text plus the key stream. Um, but whenever you have more options that a character can be, versus from the original 26 to however many this is, it just makes it that much more secure for people who don't have your key. If they don't know your primer, then they have to try a lot harder and guess a lot more if they're going to figure it out. So this will be the last one that we do that is this simple letter stuff. After this, we'll be going into some modern computing with some binary, with some hexadecimal, all of that good stuff. ASCII will get in there too. But I wanted to go through this and talk about one last thing before we get into actual programming portion of it. And I'm going to talk about what's called frequency analysis. Frequency analysis. So basically, part of the reason that is more secure is because the frequency analysis aspect. If you look at it, you look at the frequency of the letters. So in every sentence, E is the most common letter and A is the second most common letter. And so if you make a bar chart, let me just Google a picture here. Excuse my background. If you look up frequency analysis bar chart, you can just see all these things, right? So we're going to look at cryptography at the end because it's specific. And this is what a regular frequency analysis bar chart looks like. It's a little bit different from the other ones you saw, but there's every letter and everything has what is a percent. If you add all these up, it'd be 100. But something that's important to note is that it's pretty easy to break a cipher if you have this frequency analysis. For example, if you look at this, E is the really big one. It goes down for D, down a little more for C, down a little more for B, and then back up to A. Now, every sentence, every word will have its own individual, letters and different percents, but the trend is still big E, little, big A. So like we can look over here. Now, if we look at this one, R is really big, goes small, goes small, goes small, and then pops back up for N. So basically, if this was like a Visioneer cipher, if this was a auto key, if this was even a Caesar cipher, you could then go through and look at it. A Caesar cipher will be it'll be in the same orientation because it's just shifted. The alphabet is just moved over, so it'll have the exact same shape as this, or at least very similar shape, except it'll just be slid across that axis a little more. And you can use frequency analysis to break through the code and try and figure out what all the stuff is. I won't go through specifically how to do that during class time, but after today's lesson, I will link the North Carolina School of Science and Math textbook that I used, and that will give you some detail on how that works with frequency analysis and all of that sort of specifics. But like I said, we were going to go ahead and go through with the auto key cipher. So, auto key cipher, I have the text clean function in here. This is classic one we always have. I brought the letters function in here. And just like last week, I'm going to give you guys a little bit of help on what you will need before going into this. And then I will task you with creating the in-cipher alone. But I'm going to add an extra entry for creating the decipher and a potential third entry if you are the first submission. So it'll have a very similar startup to another cipher, at least the similar core. right? You're taking your primer and you're taking your plain text and you're adding their positions, which I'm going to actually quickly go and grab that code directly from this Vigenère cipher, because I don't want to say good programmers are lazy, but they're certainly resourceful. So we can just grab this right here, and this will still, for the most part, apply. It doesn't do it one for one, but at least this part right here, this part is the same, and that will work. So, excuse me. What are we looking for when we're making this auto key cipher? Well, I want to just highlight this part right here, that this is going to be basically the same. And you can also use this part basically from this part, right? This will be a little bit different above here. But I'm going to talk about what I have this here. This variable named vary equals a string called string text. And then we printed it with this bracket, right? We've used these before. If you remember, we'd say letters, square brackets, and then another position. If we have it right here, we can say, what's the fifth one? Oh, hang on. Let me just cut this out right now because it's not important. The fifth one is G, and you may be saying that's the sixth one. Remember, as always, Python starts on 0. So S is 0, 1, 2, 3, 4, 5 on G. So that is very important to have, because this bracket will tell you what parts you're using, which will be helpful for taking your original text, cutting off part of it, and then adding the other part from the primer. So if we went here and we said, well, we're going to take from 1 and we're going to go all the way up to 4, it will then show you these from 1 to 4, TRI, which is very helpful because we are going to need that. In this cipher, I'm going to leave this a little bit more open for you guys to take over, but I will tell you that you're going to have to take your original plain text, and you're going to have to find out how to get the correct amount. So you're going to need to use inside these brackets, you're going to need to find len, which is the length function, parentheses, the text to find that. You're going to have to do the length of the primer, and you're going to have to add that, which I will give you guys another little reminder here. If we have our second variable, and we're going to say this one is another guy, right? We can print variable plus second, if I can spell it right, and then you can see here it just straight adds it to the other one. So if you wanted to implement that, and you could say your primer plus your plain text, but then you're going to have to remember you only want a certain amount. So this is sort of, I'm more telling you guys than showing you guys, and that's the direction I want this to be taken. I will be hosting the office hours this week again, but what you can do here in this particular example, I just want to give you another little nudge. It's a shorter class for today, but we are going to get ready for this week. I want you guys to be able to spend some time preparing a statement for whoever the raffle winner is for this week's stream. I believe the game is Valorant, maybe? But there is a stream, and whoever wins the raffle will have the opportunity to share their Vigenère cipher code on stream. You have about a 5-minute block. I talked about it in the Discord. But I want that person, whoever wins, to have that time, so I don't want to have too much here. But we're going to go through, and I'm just going to quickly explain like what you could do here instead. So what I want to say here is don't want to print that quite yet. I'm going to say, for this, we're going to say the combo is the variable plus the second run that we have right here. And then what we could do is just say, let me make this a little bit easier and make this smaller so it's a little more relevant. And what we can say for our thing here is print the combo square brackets because we're going to look for something. And remember, we have right now this whole text another guy. Make that just so it's a little easier. So text is 4 characters, and we want it to go through here. So it'll basically just cut off at that R guy. Which, what we'll do is we can say, we're going to start from 0, and then that colon. You don't have to have the 0 there, but whatever. It's a little more clear. And then we're going to say, instead of giving it an exact number that I'm going to type in, I'm going to say the length of second. So now if it goes through that, it should hopefully take me to, it'll take a second because this does have more computation that it needs to do here. And yes, you can see this brought me to text another because it left out that other guy. This square brackets with colon notation is going to be very important for this assignment. And then like I showed you right here, this should be the same, except of course you won't have your key stream here. It'll be called, whatever variables apply. And this again is going to be very hard, but I will give another raffle entry available if you can make a brute force decipher. But I don't think anyone's going to be able to get that this week. Prove me wrong though. If you can make a brute force decipher, which, just a reminder, is whenever you are given the ciphertext but you don't know the key. In this case, you don't know the primer. You're trying to guess it with the brute force. So if you can make that, that is an extra point to the $25 raffle. If you have any questions, feel free to DM me. I will have office hours this week. And good luck.